One of the biggest differences between Magento and every other CMS platform is in the way how data is stored and accessed. Magento has a very unique database design with, believe it or not, more than 300 tables, and also a very abstracted way of handling the data in the models. In general, models are used to talk to the database, represent the data in object-oriented fashion, and perform a business logic. But if we want to further abstract things, we should mention that Magento uses three-layer approach for models. We have entity models, resource models, and collections. Entity model performs some kind of business logic, but it also gives us the access to our create, read, update, and delete operations. And that is actually done through the resource model. So entity models don't contain any database-related stuff like connecting to the database or querying the database. Instead, each model uses its resource model class that communicates with the database via adapter and perform all of your CRUD tasks. By separating the logical model or entity and the code that talks to the database or resource models and adapters, it's possible to write new adapter classes for different databases while keeping your models untouched, which is the biggest advantage of this abstraction. Now, before we dig into the code, we need to talk a little about different types of models. Magento has very simple models where each record in the database is a distinct thing. So you have a table like config data or URL rewrites where each row represents a complete information about entity, and that's a concept you're probably familiar with. There are also some more complex models like CMS pages or even more complex like sales quotes and sales orders. These involve more than one table to really get complete record of something. And finally, we have EAV models. Examples of EAV models are products, categories, and customers. These are the most powerful, they give you a lot of flexibility, but of course with a little bit of overhead. Just look at the database, products and categories data is stored in almost 50 tables. That's why EAV is one of the most complex parts of the whole system. The great thing though is that you don't need to explicitly know how the database internally works, because you'll heavily rely on Magento ORM, which will allow you to work with the data using objects. That's what we are going to learn, and once you feel confident with that, then you can start EAV researching on your own. But of course, I'll give you the basics as a quick start. So, EAV stands for Entity Attribute Value, where entity is a thing that is being modeled. Think of products, categories and customers as entities. Now, entities have a number of attributes. That's what A in EAV stands for. Entity attributes actually work much like regular properties of an object. And of course, each attribute has some value, that is what V stands for. Here we have a traditional customer table. Again, each column represents some data, and each row is a complete set of information about the entity. That's nice and simple, but it's a little limiting though, because suppose you're modeling a customer entity having large number of attributes. Let's say you need 50 columns, but not all of them are necessary in every case and for each customer. You'll end up with a big table with a lot of null or empty values inside. And that's one of the things EAV solves. The traditional model could be replaced by EAV having three tables. In the first table, we have our entity with basic or scopeless data, which is always required. Then we have information about attributes, which is kind of meta information about the entities. So in this table you store attributes that any of the customer entity may have, and you can see that adding a new attribute simply involves adding a new record in the EAV attribute table, so no need for table altering in order to add a new column, which you would actually do in traditional approach. And then in the third table we can see the content itself for a particular attribute on particular entity. And that's EAV in a nutshell. Magento of course has some more abstractions on this, but as I said, you don't need to worry about that. Instead, let's focus on the things that really do matter, for example how resource models are defined, how they are connected to the models, and how we can take advantage of the whole architecture as well. In this lesson we'll be dealing with simple models, and EAV models are exactly the same for the most part. I'll choose a random model for demonstration, for example CMS, why not? We know that the same rules apply to all other modules. So CMS model entities are stored in model folder, and both of them are really tiny. you won't see any SQL because they don't know anything about database. They deal with it through their resource models. Resource models are stored in here. CMS has two resource models obviously, block and page. And this is interesting. If you look into MySQL 4 folder, you'll see the exact same structure. I'll open block PHP and notice it is all empty. It just extends from Mage, CMS, model, resource, which is this file, under resource model. And the reason why we have something like this is because multiple database support was introduced with Magento 1.6 version. Prior to that, resource models, beside other things, had some MySQL specific operations, so the core team decided to further abstract things and move those database specific code to the adapters, which is another layer below the resource models. So now resource models still build queries, work with data types, fetch records and so on, but whenever they need to make a query that varies among different database vendors, they use an adapter. You can have MySQL adapter, Oracle adapter, and so on. This logical change also implied physical changes in class names and folder names. Resource models, previously named as namespace, module name, model, MySQL 4 name, were renamed to namespace, module name, model, resource name. Once again, because they're not strictly oriented to MySQL anymore. So, although MySQL 4 naming convention is deprecated now, they wanted the system to be backward compatible, and the simple solution was to leave all those MySQL 4 folders for now, but as you see, classes are empty and they extend from the corresponding class in resource folder. Okay, we saw where our resource model classes live, but that doesn't mean anything to the system, so we need to let it explicitly know about our resources, and of course we do it in config XML. It's pretty straightforward, because resource models are configured in the same section as entity models. We just need to add the resource model node below, and this string here becomes another node, and that in turn contains a class prefix, so whenever you try to call mage, get resource model and pass cms/page as an argument, the system will go to models, CMS node, then read the value from here, then go to that node and find the class prefix. And whatever the class prefix is, it will use it and append on the end everything after the slash in getResourceModel call, which is page. That's how Magento gets the full resource class name. So basically we have two similar calls with the same argument, mage getModel and mage getResourceModel. But this one will instantiate mage CMS model page or entity class, while the second will return mage CMS model resource page or resource class. And now when we have both entity and resource models configured, the system is aware of them, but at this point they are not connected with each other, and that's something that we need to do manually. I'll open page PHP in order to find out what core developers did. Look at this protected method construct, and it is not PHP construct method. This is Magento construct, notice 1 underscore at the beginning. So it initializes resource model by calling another protected function in it, and what you pass here gets passed to set resource model in mage core model abstract. And that's one of the reasons why models need to extend from that class. Okay, so by calling this, our entity and its resource model gets connected. And in the resource model class, there's also construct method and init call with the exact same first argument. The second one is the primary key of the database table this model needs to talk to. And by the way, the system knows what table to look at from the configuration. This is why we have entities and table names inside. So page entity uses these two tables, while block uses these two. And these nodes are used to reference the table in the query. So if we'd like to get some data from CMS page store table, we can reference it by this table alias and pass table alias as an argument. On the other hand, CMS page is the main table for page entity, and we have very semantic getMainTable method available. I'll show you on the example of getCMSPage titled by ID method. You can see this getMainTable in form part of this query. Okay, We covered entities and resource models, but what about collections? We said that collections are another type of model and they are very useful when you don't want to fetch only one entity model by some argument, but you want collection of that entity objects. For example, on category page you have collection of the products that belong to that category. We'll cover collections in full in the next lesson, but for now let's look at basic setup. So in order to use them, you need to create a file collection.php in a separate folder with a name based on the model name. So the folder where you define your collection class will always have the same name as the entity itself. And then, just as with our resource model classes, we need to init our collection with the model URI, which is cms/page. And that's all. You don't need to configure anything in config.xml because Magento sets collection object for you. I think it's not that hard, at least it shouldn't be after reviewing this lesson a couple of times. It's a good introduction for the next lesson where we'll put our hands on these things. See you there!